Hello. So today we'll be doing another quick question. Not on Leetcode again, I don't think. Um, and yeah, so given a binary tree and a node, find the level order successor of the given node in the tree. The level order successor is the node that appears right after the given node in the level order traversal. So level order traversal is just breadth first search. And so, that's what we've been doing so far for like the past few days. Um, yeah, I think that's all there is to describe about the problem. I should probably let me put the answers to the questions right underneath them. So this one, answer should be 4. This answer should be 10. And this answer should be 7. Is that correct? 4, 10, 7. Yep. Okay. So back to the problem. So yeah, we just want to do a simple breadth first search. And whatever we find will be the answer. I guess breadth first search you could technically do right to left as well. But since I think it just naturally assumes that we always do it from left to right. So for the sake of the problem, if you were to do this on your own, make sure to do breadth first search from left to right instead of right to left, even though you technically wouldn't be wrong if you were to do it from right to left. Okay, so with that being said, we'll start the problem now. So if root is none, then there can't be any successors, right? So we'll just return none right there. And now this is where we have not a problem, but it's like, oh, we have more things to deal with. So we're going to create a queue using dequeue. So we have it imported right here. Queue.append root, because at this point we do know that root is not none. So we will do while length of queue does not equal to 0, which just means there's something in the queue, right? You could technically do you could do while true, I guess, and have a check inside, or while length of queue is greater than 0. Doesn't really matter, since the length shouldn't ever return a negative number to you anyways. This works. You could find some other way to calculate it if you want, but this is simple enough and we'll just go with it. So node equals queue dot pop left, because we want to take it out of the front of the queue, because first in first out. So the one difference from, I guess, this problem compared to previous problems is previous problems will calculate the logic. So here we would do like if this, then we'll like do whatever we need to do here, right? And then we would do the if node dot left is not none, then queue dot append node dot left, and then if node dot right is not none, then queue dot append node dot right. See, that's what we would normally do, right? But instead we want to put this up here this time, because in this question, if you have root here, root is only one node, right? So in the first instance of this problem, assuming we get the node that, so assuming this key points to our node, like the node that we're looking at right now, then we would have nothing in the array, right? Or like in the queue. So we have to append these, like the children first, and then like obviously if they're both none and it's just the root, then like, but then it's possible where we're looking at the root, like in this case, right? We look at the root here, and so we want the answer 7. But if we were to do the appending of the children after the fact that after we do the check here, that wouldn't really work, because we would we wouldn't append the children first, right? So that's why we need to have that check up there first. And let me just make sure we're in the right place with our tabs. And so here we're going to be doing a bit of a complex, it's not complex at all, but like it's a little bit more complicated than your typical return statement. And I'll type it out and then I'll explain what it does exactly. So return none if length of q equals 0, else q.pop left. And then let me just finish off the problem by doing the return none here. Basically, it's just saying we never found the key, and there's no more children to be put on the tree, so we'll just return none. So in order to explain this thing, it's essentially the same thing as doing if length of q equals 0, then return none. I don't know how to do my spaces anymore, else q.pop left. Let me just comment this out really fast. So this return statement is exactly the same as this, but it just makes it a lot shorter for us to type if we were to do this, if that makes sense. Yeah, so I guess that's the explanation of this. That's a pretty simple question. We are done here. If we run Python file in terminal, we get the answers 4, 10, and 7. If we look, root is, okay, so here we're looking for 3, right? So 1, so the tree looks something like 1, 2, 3, and then 4, 5. And so like 4, 5 are children of 2, right? And then 3 is just on its own. I'm not going to format thing, but 3, so 1, 2, 3, 4. So that's what it would look like. That's why that's the answer. For this question, it's a 12, 7, 1, 9, and then I'll put like 2 spaces just to show that these belong to 1. So 12, 7, 1, and we're looking for after 9. So actually the space doesn't really matter in this case because we're looking for after 9, so it's 10. And then we look at the root 12 here, so then we look at the answer would be 7. And then we can do another one, pretty simple actually. We'll look at, what node is this? 5. Because 5 has no children and there's nothing after it, right? So this should be none. Okay, so I'll just add another condition just so there is no value to, there isn't a node. There is, what should I type? There isn't a node after this. And I'll just have it for this case because the other ones we know have answers, right? And this, if we did everything right, you should print this. And so let me just delete that terminal just so we have a fresh instance. And boom, there isn't a node after this because there's nothing after 5. So there we go. Yeah. So that being said, this is the code again. And yeah, that'll be it for this question. Thank you for watching.